Hey everybody, Miss Dietrich here. We're taking a look at question 9. What is the volume of the solid figure shown at the right? So they're talking about this thing. Now, we have a couple approaches that we can take. We've talked about 2 approaches in class. One approach is that we can pretend that we don't have a cutout, that we have the entire rectangular prism, and find the area of the entire prism as though we had it. And then we can, write that number down. And then we can find the area of this, cutout piece, or not area, I'm sorry, volume, and subtract that volume out from the entire thing. That's one option. The other option is we can break this up into 2 separate rectangular prisms. So we could find, what we might call this bottom chunk, and then find the top chunk, and then add those 2 together. So there's not a right or wrong way to approach this, but if you do it this way, you have to be careful because you have to take into account that this piece on the bottom, we're already counting it if you break it up this way. So you have to decide if you're going to break it up in a horizontal way or in a vertical way, and make sure that you don't include chunks that you've already included in the other prism. So in my opinion, this way is a little dangerous because I've seen people make that mistake that I just spoke of. So let's focus on, the idea of doing it the way that I proposed, which is pretend that we have the entire prism. So if we had the entire prism, then we're looking at, this line, we're looking at this line, right? So let's kind of visualize, what that would kind of look like, right? Because we're talking about finding the blue prism. So that would be volume equals length times width times height. Volume equals, and the length on this thing, let's use this as the length, the 5.5. I'm going to turn it into, actually we can turn them into decimals because we don't have any of those non-terminating fractions, so we should be good to just turn that into 5.5. All right, now the width on this thing, let's call this the width. So it seems like they're pointing at this line right here to represent, the length of that line, and they confirm it by showing you this also, which is parallel to it. So that's going to be 1.5, that's equal to 1.5. And then the height of this thing is right here, it's 6. All right, so let's take out our calculators and find that product. 5.5 times 1.5 times 6. And we get this number, 49.5. All right, let's write that number down. 49.5. All right, and again, that's, assuming that we have the blue rectangular prism. So let me put that kind of off to the side, see if it'll let me do it all in one shot. All right, kind of did. All right, and now let's focus on this piece that's a cutout. It's not part of it. What are the dimensions of it? So I'm going to pull it over here just so we can kind of focus on it. But we basically need to figure out, how long is this line right here? How long is that line? Because that's going to represent one of the dimensions, right? Now, a way that we can figure that out is that we know that this line would be the same as adding this red line and adding, how about we use this line right here? And I'll move that down so you can see why that's true. So the red line and the yellow line together have to add up to be 5.5. So if we take 1.5 away from that number of 5.5, then that should give us what the red line is. Okay, so let me try to say that again because that's a mouthful. The yellow line and the red line together have to add up to be 5.5. So if we already have 1.5, let me write this down so you can kind of see it. So 5.5 minus this 1.5 will give us the length of the red line. All right, so 1/2 minus 1/2 is a nothing. And then if we do 5 minus 1, we get the 4. So that line should be 4, right? The red line should be 4. So I'm going to write that right here so we keep track. All right, so we have that line. Now we also need the length of this line. Now, is that explicitly stated? It's not. It's not explicitly stated, but we can infer it. How do we infer it? Because we know that this line is 1.5 right here. So let me highlight that in green. Wrong color. Darn it. Let me erase all of this too so we don't get confused. So the length of this line, which I meant to highlight in green, and I'll highlight it here, that line plus this line together would have to be 6. So if this is 1.5, we really just need to subtract 6 minus 1.5. So that's the same thing. If we do this is 5 and this is 2/2, and we go ahead and subtract, see that's going to be 1/2, and this minus this would be 4. So it's 4.5, right? That red line is 4.5, which means that this is 4.5. All right, so let's move that. Let's put that over here as our dimension. All right, and we already know that this line going this way, which I'll do in yellow, we already know that that line is 1.5 because they tell us that it's 1.5. They show us up here, this line is 1.5. So let's write that number down like so. All right, so to get the volume of this thing, we would have to go ahead and multiply the length. So let's call that 4. The width, we'll call that 1 5/10, times the height, which is going to be 4 5/10. All right, so let's take out our calculators. 4 times 1.5 times 4.5, and we get this number, 27. So that's how many cubic centimeters the hole or the cutout is. So that's how much this piece is. It's 27 cubic centimeters. So the only thing left you have to do is subtract this number right here, which I'll highlight in yellow. This number, subtract that number from this number, and you'll have your final answer. All right, good luck finishing that up.